Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about how to graph piecewise functions. This is one of the hardest things to do in algebra or pre-calculus, but we're going to do it right now. So first of all, in case you're wondering what we're talking about here, piecewise functions are functions that have the curly bracket. They usually have one function on top for one set of values and another function on the bottom for another set of values. It looks something like this. And when you graph it, you get some kind of cool shape that looks like this. This is just an estimate for this example. It's not exactly going to look like this, but it looks something close to this. You may even notice the open and the closed circle. I'll be talking about that too. But before we talk about how to graph these functions, let's go over my tips on how to do it. So the first thing I like to do is, for each function in the piecewise function, I'm going to graph the whole thing. When I say the whole thing, if the function is y equals x plus 1, then I'm going to graph x plus 1, not just for the x values they want me to, like let's say x is less than 5. I'm going to graph it for the whole thing lightly, because I'm going to erase it later. And I'm going to do that for every part of the piecewise function. And then step 2, I just need to erase the part of the graph that's outside the domain. So for instance, if it says x is less than 5 for the condition, then I'm going to erase everything that's greater than 5 because that's out of the domain. And I basically do these two steps for every part of the piecewise function. And let's say you don't know how to graph part of the function, that's okay. You can basically, instead of doing step 1 and step 2, alternatively, you can just do a table of values. So in other words, you just plug in values for x inside your domain, of course. Like for instance, if it's less than 5, then I would do 5, 4, 3, 2, etc. And then I would get the y values. But for the most part with piecewise functions, it's usually in the form y equals mx plus b, the normal equation for a linear line. So normally I'm going to know how to graph it, and you should too. But if not, you can always do a table of values to help you. Okay, so let's look at some examples. For this first one, I want you to graph the piecewise function 2x plus 2 for the condition x is greater than 1, and negative x plus 3 for when x is less than or equal to 1. So, like I said, the first thing I'm going to do is I'm going to graph both of these, starting with 2x plus 2. I know what that looks like. Let me just get some tick marks going here. So 2x plus 2 is going to have a y-intercept at positive 2 with a slope of positive 2. That means it goes up 2 over 1 to the right and down 2 over 1 to the left. And you'll notice I'm doing it for the whole graph, and I can connect these dots like this. But remember, I'm writing this lightly because I'm going to be erasing some of this in a minute. I'm keeping x is greater than 1. I'm getting rid of everything before positive 1. So since positive 1 is this point right here, then that means I am only going to keep the part greater than 1, and everything else I'm going to erase. And it's going to look like this. Now one more thing worth mentioning, this is super important. When it says x is greater than 1, when it says greater than or less than, in other words, no equal to sign, that is when the graph gets an open circle at that point. Basically, open circles, which look like this, are when you're missing the equal sign. The closed circle is when we do have the equal sign, which is going to be for the second function, negative x plus 3. So now I just have to graph negative x plus 3. I know what that looks like. It has a y-intercept at positive 3. And negative x means it has a slope of negative 1, which means down 1 over 1. And technically I don't need to keep going down and to the right because I know I'm going to be erasing those points anyway. So instead I'll go up and to the left like that, and then I just connect the dots. And since I want to keep x equals 1 because of the equal sign here, that means it is going to be a closed circle at that point. And I can erase the dots I drew earlier if I want to make it look nicer. It's technically not wrong if I have the dots, but it does look nicer if I erase them. And there we go. There is my piecewise function. As you can see, not too bad. It was as easy as graphing two linear lines. So let's do another example, and this one will be much harder. but give it a shot. For this one, I have f of x equals, make a big piecewise function because this time we have 3 parts. The first branch is going to be 4 minus 1/2 x, breaking out the fractions here. And this is going to be when x is less than or equal to -2. For the middle branch, it's just going to be a positive 1, and that is when -2 is less than x, which is less than or equal to positive 3. You'll notice this is sandwiched between 2 values. Fine. And then the last one's going to be really hard. It's x squared minus 2x minus 2, and that is when x is greater than 3. So the good news is the process doesn't change even though I have 3 branches. The first thing I'm going to do, I'm going to try and graph 4 minus 1/2 x. So I'm going to make a bigger graph this time. So if I want to graph 4 minus 1/2 x, that's going to start with a y-intercept at positive 4 right here. And with a slope of -1/2, that means down 1 over 2, down 1 over 2. And on the other side, it's up 1 over 2, like that. And then I'm making a line that connects all these dots. Again, lightly, because I'm going to be erasing some of these. So what am I going to erase? Well, x has to be less than or equal to -2. Less than means left. Don't forget that. So I want to keep the left side of -2, which is right here. So in other words, I'm going to be erasing most of this graph. And on top of that, since the top function does have an equal sign, it means it is going to have a closed circle in the graph, which is going to look like this, roughly. Okay, so that's it for the left portion. Fair enough. Now the middle portion. The middle portion is both the easiest and the hardest. It is the easiest because if you know what to do, this is incredibly easy. And it's very difficult if you just see a 1 there and you're confused. So basically what this means, between -2 and positive 3, the y value is just 1. The slope is 0 because there's no x. It's just a horizontal line at 1. It's very easy. On top of that, since -2 does not have an equal sign, it's going to be an open circle at -2, and 3 is the closed circle. So here's what it's going to look like with the y value being 1. Open circle there, closed circle at 3, about here, and then just a horizontal line at positive 1. And that's why we love constants, because they are very easy to graph. And then for the last one, when x is greater than 3, x squared minus 2x minus 2, there is no easy way to graph this. I would use a table of values. It makes it so much easier. And as a piece of advice, since it says x is greater than 3, when I make my table of values, I'm going to choose values starting at 3 and going up. I don't want to go too far because it gets ridiculous. And another thing, you might be thinking, hey, Dan the tutor, x is greater than 3, not equal to, so shouldn't we not include 3? And of course, you're wrong for 2 reasons. Number 1, it's Mr. Dan the tutor to you. And number 2, I still want to plug in 3. I just want to have an open circle at 3. I still plug in 3. So plugging in 3, 3 squared minus 2 times 3 minus 2. I'm just going to tell you, you get 1. If you plug in 4 for x, you get 6. If you plug in 5, you get 13. And I'm not even going to bother plugging in 6 because it's going to be off the graph because 13 is off the graph already. But now just plugging in those points, remember the points were x equals 3, y equals 1, which conveniently enough is on top of the closed circle. Which then begs the question, what do we do when there's an open circle and a closed circle on top of each other? The answer is, you just write the closed circle. You do not circle it with an open circle or do anything silly like that. You just leave it like that. That's it. Then when x was 4, y was 6, which is like up here. And at 5 we got to 13, which is way too high. So then finally I'm just going to connect these dots. And I know x squared is a parabola shape, so I'm just going to make it a little bit curvy like that. And even though it might not be perfect, this is a perfectly good, acceptable answer. And so you will notice at x equals -2, there is a jump, and then at x equals 3, the points met up. Sometimes they meet up, sometimes there's a jump. It doesn't matter. This is the correct answer for this one. And that is all the problems I have for us today. If you do have any questions, please post them in the comments. Thank you all for watching. My name is Mr. Dan the Tutor, and I will see you in the next video. Take care and bye-bye.